Guys, this is the sand pile example. So sand is being dumped into a conical pile whose height is half the radius of its base. Suppose the sand is being pumped at a rate of 5 cubic meters per minute. There's 3 parts to this example. So part A is asking us how fast is the height of the pile increasing when it is 9 meters high. So we are given the formula for the volume of a cone here. It's V is equal to 1/3 pi r squared times h. And looking at this first question, we are given dv over dt. So we are given the rate at which the volume is increasing, that's by 5 cubic meters per minute. And we are being asked to find dH over dt. Now, we're being asked to find dH over dt, when h equals to 9 meters. Now, looking at the equation for volume of a cone, when we take the derivative, we would end up with a dv over dt, a dr over dt, and a dh over dt. And we don't know, we are not given what dr over dt is. But we are given this information in the first sentence, that the height of the cone is half the radius of its base, meaning that 2h is equal to r, or h is equal to r divided by 2. So we can actually rewrite the equation for volume in terms of just h. Since we're solving for dH over dt, this will allow us to get rid of the r and the dr over dt when we differentiate. So 2h squared times h. So I'm just replacing the r with 2h. And when we simplify, we would end up with 4/3 pi times h cubed. So we've stated what we're given. We've stated what we need to find. And we have our equation. So we're ready to take the derivative with respect to t of each side of the equation. So we'll get dv over dt. When we apply chain rule here to find the derivative of h cubed with respect to t, we still have the constant out front. That would be times 3h squared times times dh over dt. So this simplifies, the 3's canceling, to dv over dt equals to 4 pi times dh over dt. Now we know what dv over dt is, so I can replace dv over dt with 5, and then we can just solve for dh over dt. Oh, what happened? I rewrote the equation wrong, huh? So it would be 4 pi h squared dh over dt. So this will be 4 pi times 9 squared times dh over dt. Okay, so 4 times 9 squared is 324. So we get 5 divided by 324 pi equals to dh over dt. And the units for h are meters, and the units for time are minutes. So this is meters per minute. So our sentence is the height of the sand pile is increasing at a rate of 5 over 324 pi meters per minute when the height of the pile is 9 meters high. You could get the decimal approximation too, so 5 over 324 pi is approximately 0.0049 meters per minute. Okay, part B wants to know how fast is the area of the base increasing at this moment. So when h is equal to 9 meters. So looking back at the picture we can see that the base is a circle. And we know that the area of a circle is pi r squared. So we're given the same information as before, that dv over dt is equal to 5 cubic meters. Yeah, cubic meters per minute. But here we want to find dA over dt when h equals to 9 meters. Now the thing is, when we differentiate pi r squared, a equals to pi r squared, there's no h in that formula. Wait one sec. There's no h in that formula. So we want to rewrite, there is an r though. So we want to be able to state, we can't plug in 9 meters anywhere, but since h is equal to 9 meters, we know the relationship between h and r. So that means that r is equal to 18 meters. Okay, so we've stated what's given, we've stated what we need to find. We're ready to find the derivative. So we get dA over dt equals to 2 pi r times dr over dt. Now we've run into another issue because we're trying to find dA over dt. We have a value for r that we can plug in, but we don't have a value for dr over dt. But if we go back up to the original part of the problem, notice that our equation for volume has an r and an h in it. So in part A, we rewrote the equation for volume in terms of just h, and now we can rewrite the equation for volume in terms of r. So we can replace h with r over 2. Okay, so that simplified to be pi over 6 r cubed. If we take the derivative of this equation, okay, we get dv over dt equals 2 pi over 6 times 3r squared times dr over dt. So dv over dt equals 2 pi over 2 r squared dr over dt. Okay, we have dv over dt. We can plug that in. We know r is going to be 18. So now we can solve for dr over dt, which we want to plug in up here. Okay, so if we multiply by 2 on each side of the equation, we'll have 10 equals to 18 squared. It's 324. So dr over dt, flip this around, dr over dt will be equal to half of 324. So it'll be equal to 5 over 162 pi meters per minute. So now I can take that rate and substitute dr over dt up here. Because remember, the question is asking for dA over dt. Okay, so we get, what is that? We get 10, oh, the pi's will cancel. We get 10/9 meters per minute. So the area of the base of the sand pile is increasing at a rate of 10/9 meters per minute when, you can say when the height of the pile is 9 meters or when the radius of the base is 18 meters. Oh no! Not the section we're on. Here we are, is 18 meters. Okay, and then the last part, part C, asks how fast the circumference of the base is increasing at this moment. Circumference is 2 pi r. So same given information, we want to find dc over dt when, I'm going to again say when r is equal to 18 meters. So differentiating the equation here, dc over dt equals to 2 pi times dr over dt. And we know what dr over dt is from up here. So 5 over 162 pi. So the pi's will cancel. And that is equal to 5 over 81 meters per minute. Well, I just realized the units are off on for area. That should be meters squared per minute for the rate at which the area of the base is increasing. Okay, so the circumference of the base is increasing at a rate of 5 over 81 meters per minute when the radius of the base is 18 meters, or when the height is of the pile is 9 meters. Okay.